Hello class, my name is Melanie Menudo. I'm here to talk to you about when family members look like strangers. In a case study written by Joost Huddink in 2012 explores what happens to the brain's visual receptors as a result of a stroke. The study follows a right-handed 62-year-old client during her rehabilitation following a stroke, which led to an interesting problem. JS could no longer recognize her closest family and friends. This was following an ischemic stroke. The patient could recognize strangers as strangers. She could recognize her daughter that she had not seen in 8 years. However, she could not recognize her daughter that she was seeing on a regular basis. JS was tested for visual acuity, and she passed, receiving a 1.0 or 20/20 on the vision scale. Shortly following her stroke, she was shown a series of pictures containing family members, strangers, acquaintances, and celebrities. JS had trouble picking out her family because she said that the pictures were distorted, but could not specify how it was distorted. Another piece to the puzzle was when she saw pictures of Adolf Hitler and Osama bin Laden, and she was sure that they were celebrity impersonators that were very bad at their jobs. JS was one of 4 women chosen to participate in a study, all of whom were right-handed. The other ages of the women were 58, 54, and 48 respectively. These women were chosen to be the controls of the study as they had no history of neurological damage or psychiatric illness. The dependent variables of the study was in the pictures, as they chose close family relatives between all 4 women. The pictures of close family relatives of each participant were reused as strangers in the other 3 participants' studies. The independent variable would be that of the celebrity photos utilized, as each participant had their own list of celebrities that they knew well, so each participant had their own 15 celebrity photos. As for the methodology used, stimuli consisted of grayscale images of close relatives, celebrities, and unfamiliar people. The images were sized the same, presented on a 17-inch monitor. All of the backgrounds of the images had been digitally removed and contained the same type of lighting and resolution. In total, 30 familiar faces and 30 unfamiliar faces were presented. Of the 30 familiar faces, 15 were close family members and 15 were celebrities. 3 different images of each person was included in the stimuli for the trial. The participants were presented with the stimuli in 60 trials. Each trial contained a separate warning clue, and in this case, it was a star that was utilized. After the stimuli was presented, a question mark appeared, at which point the participant could reply to each stimuli. The SCRs, or skin conductance responses, were recorded throughout the trial. The reply by the participant was either yes or recognize, or no or do not recognize the person presented on the screen. The participants were not instructed to reply quickly, but only when they were fairly confident about their response. This test took time between each trial to re-establish the baseline prior to moving on to the next stimuli. The results show an increase in response time for JS only when answering about her family. The controls show a level response time, and SCRs were higher compared to JS's results. JS responded more slowly to familiar faces than unfamiliar faces, and responses to family were slower than to celebrities. JS's response time to celebrities and unfamiliar faces were not significantly different. Furthermore, there was no significant difference between response times to correct reactions and incorrect reactions. The control participants showed significant amplitudes towards familiar faces over celebrities. JS showed a significant difference between unfamiliar faces and family. JS's SCR results comparisons showed a higher SCR magnitude for family compared to unfamiliar faces. JS reports the faces of several people looked distorted or even repulsive to her, and these distortions are face-specific. A diagnosis of prosopometamorphopsia is concluded. The control participants showed no significant stimulus type, whereas JS's SCRs peaked with familiar faces over strangers, meaning there's a connection of some kind of recognition. The strength in a study of this type is in the SCRs, a stimuli that allows a connection of understanding even if the mind does not see it. This is a rare event to be able to be studied. The control group of 3 people with no history of stroke was well chosen. The weaknesses of this study fall on the fact that JS is the only participant with a history of stroke or other illness, meaning that she is the only one that can affect this trial. The study relied upon the comprehension of JS either consciously or non, which could have gone very bad. This is a study of how JS sees her family, the dysmorphia that has come from the stroke. It is a well-designed study, however some improvements could be made. More pictures could be added in order to add another control group, either animals or places, something to add emotions. Also, before and after fMRIs testing could also be used to see new connections that were formed or destroyed by this test. Thank you for listening to my discussion.